Wow, AI is really moving fast these days. Seems like every time you turn around, there's some new big development, and it's finding its way into every corner of our lives, pretty much. Makes you wonder, how do we even begin to wrap our heads around all of this, especially when it comes to something as important as cybersecurity?
That is the question everyone is grappling with. So today we're going to take a look at the work of Michael Twining. He's a cybersecurity student over at Utica University, slated to graduate in May 2025, specializing in cyber operations, by the way.
Impressive stuff.
Yeah. And he's already got his CompTIA Security Plus and ISC2 certified in cybersecurity certifications. Shows how committed he is, considering he took a less traditional route to get into this field.
Absolutely. And what we've got here are insights straight from his recent lab work in an AI and cybersecurity course he took. Think of this as a cheat sheet for understanding AI, specifically how it plays into cybersecurity. We'll cover the basic concepts, real-world applications for protecting systems, and also look at what AI can and can't do right now.
Ground floor, first. Michael's very first lab, Lab 00, was all about neural networks, the foundation. He started by tackling the ideas of weights and bias, these core elements.
So if I'm getting this right, a weight in this network is like a number that tells you how strong the link is between those artificial neurons, like how much one neuron influences another.
Exactly. Bigger weight equals bigger influence. Then you've got bias, which is a constant value added to a neuron's activation. It's like a baseline that can shift the neuron's output, helping the whole network learn more complicated stuff.
Makes sense. So these weights and biases are what the AI actually adjusts to learn from the data it's given. Now, Michael also talked about something called loss when training AI. He said the main goal is to make this loss smaller. What exactly is loss in this context?
Loss is basically the AI's error score, you could say. It measures how far off its predictions are from the actual correct answers. During training, the AI is making guesses, and a loss function calculates how wrong those guesses are. The whole point is to shrink that loss by tweaking the weights and biases. It's called gradient descent. Kind of like fine-tuning a really complex engine to get it running just right.
That makes the picture much clearer. It's like a constant refinement process to get the AI more accurate.
Mm.
And Michael also mentioned how those large language models, the LLMs, are trained based on what Andres Karpathy said. Two main phases, pre-training and fine-tuning.
Yeah, and understanding those stages is really important to grasp what these AIs can do and the resources they need. Pre-training, that's where you feed the LLM massive amounts of text and code scraped from all over the internet. Like Michael pointed out, just downloading and organizing this huge amount of data takes serious computing power. It's the most resource-intensive stage by far.
Hard to imagine the amount of information they're using to train these things. And then you've got the fine-tuning stage. What happens there?
Fine-tuning is all about tailoring the model for specific tasks. They create these labeled data sets and use feedback from users to correct the LLM when it gets things wrong. So if the LLM gives a bad answer, a user can step in, provide the right one, and that gets added to the training data. It's more focused, targeted learning at that point.
So pre-training gives the AI this broad understanding of language and the world, then fine-tuning sharpens its skills for particular jobs. Now, Michael also listed three major things he thinks have really driven these recent leaps in AI. What stood out to you from those?
It's interesting how wide-ranging his observations were. First, he pointed to AI-driven automation. In cybersecurity, this is huge, with tools helping with things like penetration testing and security assessments for applications. But he also brought up the effects on customer service, even predicting that jobs like travel agents could be phased out as AI gets better at handling all the logistics. This really shows how AI is taking over those repetitive, rule-based tasks.
Definitely. Makes sense to have AI handle those initial customer contacts and pass on the complicated stuff to humans. And yes, streamlining travel arrangements, that sounds like a perfect fit. What was that second key driver Michael mentioned?
The second thing he emphasized was how AI can learn existing workflows, by analyzing all those tasks people do over and over. This is leading to more automation in tons of fields: marketing, investment, even data entry. The idea is AI spots the patterns in these tasks and takes over, so humans can focus on more creative or strategic work.
So not always about replacing jobs completely, but making people more productive by taking care of the boring stuff. And what was the third one he listed?
The third big thing Michael saw was how AI is shaking up industries, making them way more efficient. He used Amazon's warehouse robots as an example. They work right alongside employees to get those orders out the door faster. It's a prime example, literally, of how AI is becoming part of essential operations to boost productivity and cut costs.
That's a really good illustration. You see those robots in action, you really get the point. But Michael also brought up motivations beyond just money that are pushing AI forward, right?
He did, and it's an important point. He said AI is being used to speed up research, make technology accessible for people with disabilities, and even help tackle some of those big global problems. Think about AI potentially finding new scientific discoveries faster, helping with disaster relief efforts, or making sure everyone has access to technology regardless of their abilities. And he also made a smart observation. These non-economic goals can differ from country to country, adding a whole geopolitical layer to how AI develops.
That's really perceptive of him. So the push for AI isn't just about profits. There are broader societal goals, even national interests involved. Okay, so we've covered the fundamentals. Let's move on to the second lab, Labs '01, where Michael delved into AI and digital forensics. This seems like a really crucial area for AI in cybersecurity.
Absolutely. Michael started by explaining how digital forensics experts are swamped with work these days. Technology is everywhere, even in crime, so there's just a ton of digital evidence to deal with. He quoted Jason Murphy from back in 2022, who called it an overburdened field, and said AI could really lighten the load. Human analysts simply can't keep up with the sheer volume of data in modern investigations.
No kidding. Think about all the devices people use and the mountains of data even a single case can generate. But how exactly can AI help in digital forensics beyond just handling that volume?
Well, Michael looked at SIS's work and pointed out a few key areas. One is malware analysis, basically figuring out how malicious software works, but much faster. Then there's threat classification, spotting those unusual patterns that might signal an attack, what they call anomaly detection. And it can even help find personally identifiable information, or PII, in those huge data sets. The idea of AI helping quickly reverse engineer some complex malware to build better defenses is a pretty powerful one.
It really is. Imagine the time saved and how many attacks you could prevent. Of course, with power like that comes responsibility. What did Michael say about the ethical side of things for cybersecurity pros using AI in investigations?
This is crucial, and Michael was clear. The biggest responsibility is to double-check any findings from AI using solid digital forensics methods. AI should be a tool that makes human analysts better, not replace them entirely. He also said it's super important to make sure that whatever AI techniques are used, they line up with the legal standards for evidence, so everything's admissible in court.
So basically making sure those AI-driven techniques are reliable and pass muster with the legal and scientific communities. What other ethical points did he bring up?
He stressed the need to look closely at what assumptions those AI algorithms are making. AI runs on the data it's trained on, right? So there's a chance it could have built-in biases, or there could be flaws in how it's designed. Any conclusion AI comes to in a case has to be carefully checked to make sure it's relevant and not based on some hidden bias. You can't just blindly trust the output.
Makes sense. The training data might not be perfect, or there could be unintentional biases in the algorithms themselves. Michael also talked about how using AI in digital forensics creates some challenges for the traditional legal standards for evidence, right? That sounds like a tricky area.
It is. One of the biggest challenges is that you still need skilled investigators, people who can make sense of what the AI finds and back it up. Even if the AI flags a piece of evidence, a human expert has to explain how the AI got there, especially since there's always a chance the AI could be wrong or have used faulty methods. This is crucial if you want to use that evidence in court and avoid legal challenges.
So AI can be a bit of a black box sometimes, and that's a problem in court where everything needs to be transparent and explained clearly to prove the evidence is valid. Anything else he highlighted about this?
He also brought up concerns that AI might not always follow the established best practices in forensics, like hashing evidence. Hashing creates this unique digital fingerprint for a file, and it's a fundamental way to guarantee that a file hasn't been tampered with. It's all about making sure every action leaves a trace. If AI systems aren't consistently using these proven methods, it could raise red flags about whether evidence has been altered or if the AI is generating inaccurate information.
That is a big deal. Being able to prove that evidence hasn't been tampered with, that whole chain of custody, it's a cornerstone of any legal case. So what did Michael suggest to make sure AI findings in forensics are accurate? What procedures did he outline?
He said the validation process for AI should be just as rigorous as it is for findings from human analysts. That means understanding exactly how the AI found a particular artifact, being able to reproduce that process yourself, and using all the standard forensic techniques to make sure that evidence meets the high bar for court. Thorough documentation is key. A clear chain of custody, providing those cryptographic hash values and explaining why each piece of evidence matters.
Sounds very thorough. It's like treating the AI as another investigator whose work needs to be independently verified. And what about how the original evidence itself is handled?
Super important point. Michael stressed that AI systems should only work with copies of evidence, never the originals. This way, there's zero chance of accidentally messing up the real evidence. And he also advocated for a standardized framework for using AI in digital forensics. This would make sure everyone's using it consistently, no matter who the expert is or where they are, which could help avoid arguments about whether evidence analyzed by AI is valid in court.
Standardization seems essential if you want people to trust these tools and for the courts to use them effectively. Now, Michael also compared existing forensic tools to AI and talked about AI's potential. What stood out to you from his thoughts?
He pointed out that a lot of the tools we already use for forensics are doing things that people think AI could do, like analyzing a computer's RAM or figuring out what type of file something is based on its characteristics. In those specific areas, AI might not be adding much right now. But he did see huge potential in AI's ability to find connections between data that seem totally unrelated connections a human analyst might miss. He compared it to those AI-powered SIEM systems, the ones that connect security data to known threats, and imagined a similar crime feed for forensics experts.
That's a really interesting parallel, using AI to link those digital clues to known criminal activity, basically enhancing the expert's ability to put the puzzle pieces together. So his take was that AI is more of a helper for experts, not meant to replace them, right?
Exactly. He was very clear that human expertise is still absolutely essential for understanding the findings, seeing the bigger picture of an investigation, and making sure whatever conclusions they draw will hold up legally. AI can crunch the data, but it's the human analyst who provides the critical thinking, judgment, and understanding of the context.
All right, so we've got the basics down and a major application in digital forensics. Now let's jump to the third lab, Lab O2, where Michael got to work with a bunch of current AI models: Sora, Claude, Bing Image Creator, Udio, NotebookLLM. Sound like you did some cool experiments.
He did. He explored both the creative side and the analytical side of these AIs and started to see where they're limited right now. For instance, he asked Claude to write a rhyming recipe for shrimp scampi. The AI managed to rhyme, but the rhythm felt off, not how a human would have written it.
That's a really interesting example. The AI can get the basics of human creativity down, but it misses those subtle things that make it feel natural. What other tests did he run?
He tested Claude's math skills, asking it to multiply two pretty big numbers without using any calculators or anything. The AI got an answer that was close to the right one, but not quite there. Michael figured that the AI's logic for multiplying was good, but it seemed to have slipped up in the last step when adding everything together.
So it understood the process, but fumbled the execution. It's a reminder that even these advanced AIs can still make basic math mistakes. What about the image and video generation tools? What were his experiences with those?
He asked Bing Image Creator to show him a white Samoyed husky playing tennis on the moon. It did make images, but they didn't have a proper tennis court. And the dog, the racket, the moon surface, they all looked kind of separate, not like a real scene. It also forgot that you should be able to see Earth from the moon. Then he tried Sora to create a short video of the same thing. It did show Earth in the background, which was better, but it missed things like the tennis ball bouncing and the husky actually holding a racket.
So these creative AI tools can make some impressive images and videos, but they're not always great at showing complicated scenes and how things interact realistically within those scenes. They get the individual parts, but not always how they fit together naturally. Now, Michael also thought about how these systems could disrupt different industries based on what he saw in his experiments. What were his ideas there?
He saw a big opportunity in the music and film industries, thinking about how you could use tools like Udio for composing music and Sora for video, making it much easier to create music videos or even short films. He also thought marketing could be significantly affected, with things like Bing Image Creator and Claude making visuals and text, and Sora creating dynamic video ads. He even imagined more interactive robots for customer service and manufacturing.
AI-driven marketing content that's more engaging. Definitely seeing that trend already. And yeah, more advanced interactive robots could change how customer service and manufacturing work. What other disruptions did he predict?
He also mentioned content creation for things like blogs and podcasts, specifically saying how NotebookLLM could be used to make content from those huge data sets of information. He even included a link to an example of a podcast outline it created based on some stuff he uploaded.
That's kind of wild, an AI helping to make a podcast about AI. Definitely shows how it could change how we create content. Now, Michael also talked about the future of AI, specifically this idea of agentic AI. Can you explain what that is?
Agentic AI is a step beyond what we see now. It's not just about giving information or making content. It's AI that can do things based on what you ask. Michael gave some examples like AI planning and booking your whole trip, or creating a website that's interactive, maybe a custom study guide or something. He mentioned Manus as an example of a platform working on this. It's about AI going from a tool that reacts to what you do to something that's more proactive, an assistant that takes initiative.
So moving beyond just answering questions to actually doing complex tasks for you. That's a big change. But what did Michael's experiments reveal about what AI still can't do? What are its current limits based on his hands-on work?
He noticed that the AIs he used couldn't post on social media by themselves or schedule and complete tasks without him telling them to. And he saw that robots generally can't really create new ways to learn things. They mostly stick to what they're programmed to do. He talked about the robots at his workplace, ACCO brands, which stack pallets. They just follow their programming. They don't figure out new, more efficient ways to stack based on the space they have. He contrasted this with how humans can adapt to situations and think creatively.
Really important distinction. AI is great at those repetitive things, but it's missing that adaptability, that human spark of creativity and problem solving. It's mostly limited to what it's been trained on or how it's programmed. What else did his testing reveal about AI's limits?
He thought NotebookLLM seemed to be the most accurate overall, probably because it's built to focus on specific types of documents for things like making podcast outlines or study guides. Suggests that a more specialized AI can be more reliable in its own area.
Logically, it makes sense. When you narrow the focus, you can improve performance in that specific domain. Lastly, Michael briefly touched on a big issue as AI becomes more common: security. What were his main points about the security of these systems?
He brought up a crucial point about AI being vulnerable, particularly those large language models that could be handling important business stuff remotely. Imagine if someone slipped in bad data, manipulated data during the AI's training. The results could be really unpredictable, even dangerous. He emphasized the growing need for better security around that training data and setting up solid rules for how AI is used. He even said that for companies dealing with very sensitive information, running LLMs on their own servers in-house could be a more secure way to go, keeping that data under their control.
That's a major concern. As we depend more on AI, protecting it and the information it learns from becomes absolutely critical. It's a scary thought how someone with bad intentions could exploit these vulnerabilities.
Absolutely. So to sum up our deep dive into Michael Twining's labs, we looked at how neural networks work, the potential of AI in key cybersecurity areas like digital forensics, and got a realistic view of what some of these cutting-edge AI models can do, as well as where they fall short.
And for me, some of the biggest takeaways were understanding how those loss functions work in AI training, the legal and practical challenges of using AI in forensics, and how those AI models Michael worked with had this mix of impressive creativity, but also these basic limits.
Exactly. It shows us that while AI is a powerful tool that's evolving fast, it's not a magic solution. Using it effectively and responsibly means thinking carefully, setting clear guidelines, and keeping humans in the loop, especially in critical areas like cybersecurity.
So with everything we've talked about today, with AI getting more powerful and showing up everywhere, especially in cybersecurity, what's the final thought you want to leave our listeners with?
Here's the question we all need to be asking. With AI getting smarter and becoming part of essential systems and handling sensitive data, what can we do right now to not only harness its potential, but also manage the risks? This means setting clear rules for how it's used, implementing strong security measures, and fostering a culture where we're always learning and critically evaluating these technologies. It's all about finding that balance, embracing the incredible power of AI while being responsible stewards of this technology.